Hello, this is a Laplace transform question from 2018, semester 6, question 1. It says determine the inverse Laplace transform for s plus 2 over s squared plus 6s plus 8 using the Laplace transform tables, and it's worth 7 marks. These tables will be given at the back of the exam question. So what basically we have to do is, if you have the Laplace transform tables, we have something here and we have to do the inverse Laplace transform and get to the left hand side of these tables. So when we do the inverse Laplace transform, we've got something in terms of s, a function in terms of s, and we want to bring it to the left so we get some function that's in terms of t. Now the only thing about the question we're given here, this s plus 2 over s squared plus 6s plus 8, doesn't look like anything on the right hand side of the table yet. So the whole point of this question is to try to change it so that this here looks like something on the right hand side of the right hand side of the tables, so we can turn it into something, or just read the tables and get it as something on the left hand side. So if we try to sort out this s squared plus 6s plus 8, first of all, the bottom, and it's going to end up looking like one of these here. So that's what we try for. We're going to get a square in it. So if you have s squared plus 6s, what you do is you look at the coefficient of the s, and divide it by 2, and you'll get s plus 3. So that will be s plus 3 squared. And we're doing this as a trial to see what this looks like compared with the one we're given in the question. So s plus 3 squared, that's s plus 3 times s plus 3, which works out as s squared plus 3s plus 3s plus 3 3s are 9. And that works out as s squared plus 6s plus 9. So if you compare this with that, the only difference is 1. S plus 3 squared is 1 more than s plus 8, than the s squared plus 6s plus 8. So we can write that s squared plus 6s plus 8 is equal to s plus 3 squared, which is this. And if we take 1 away from it, minus 1, that would bring that 9 down to 8. So now this does look similar to something on the bottom of these here tables. It looks like either this or this, right? And it's s plus a squared minus b squared. Well, 1 is the same as 1 squared. So we have it in that form now, where a is equal to 3 and b is equal to 1. So we have it as s plus a squared minus b squared. We have the bottom part sorted. So then we have to look at the top part, and it's s plus 2. So we have s plus 2 over s plus 3 squared minus 1 squared. Now if you look at, it's s plus 2, not s plus 3. That's s plus 2 up there. It would be easier if it was s plus 3. Because if you look at this, the s plus a squared plus b squared, or s plus a squared minus b squared, has a b on top, or it has an s plus a on top. So therefore, to sort out the s plus a, if we had s plus 3 on top here instead of s plus 2, then that would be similar to this. And I can sort that out, because I can say s plus 2 plus 1 minus 1 all over s plus 3 squared minus 1 squared. So we've added 1 to it and we've taken 1 away from it. So that still is effectively s plus 2. But I can split it into s plus, if I join these two together, 2 plus 1, 3, minus 1, all over s plus 3 squared minus 1 squared. Now I can split this, as you can split, say, a plus b over c. That's the same as a over c plus b over c. I can split this fraction here, so I can split that into s plus 3 over s plus 3 squared minus 1 squared minus 1 over s plus 3 squared minus 1 squared. Now have a look at the tables and see, is this similar to any form here? And it is. It's the same as that one and that one. So it's actually the same as in the tables we're given s plus a over s plus a squared minus b squared minus b over s plus a squared minus b squared. This is the form we see on the right hand side of the table. And in this case, it's still that A equals 3 and B equals 1. So now I can rewrite the whole thing, the inverse Laplace transform of s plus 2 over s squared plus 6s plus 8 is equal to s plus 3 over s plus 3 squared minus 1 squared minus 1 over s plus, well, the inverse Laplace of them, minus the inverse Laplace on this, s plus 3 squared minus 1 squared. So we have to get the inverse Laplace. To get the inverse Laplace of that, so we have to get the inverse Laplace of this minus this. So from the tables, with the s plus 3 on top and the minus b, that's this one, it would be e to the minus at cos bt. So that would be e to the minus at cos bt minus, and if you look at the inverse Laplace for the one with just the b on top, it's e to the minus at sinh bt. So that's in the tables. And if we put in our values, we have a as 3, so that's e to the minus 3t cos 1t, or just t, minus e to the minus 3t sinh 1t, which you write as t, and that is your answer.